Hi, Rob. How are you? Did you all hear me? Thank you.
Hey, sorry, I'm having trouble copying something, but yeah, I can hear you and we see you fine, and I'll get everything fixed or corrected
All
here in
right.
just a second. Screens.
Okay. Thank you.
Thank you. Hey, Mike.
Got a minute, Rob. He'll be back.
Okay. Hey, Mike.
Yes.
One just let you know, after class, I'm going to take your all the attendance from the semester and put it in your pickup box. Unless you want it in the blue box, I can put it over there. Whatever's best for you.
Yeah, no, I got to be at school at 8:30 in the morning. If you'll just put it in that box in his office, that'd be perfect.
Okay, I'm going to have a few tests that I've never seen the people since I took them as well, just so if, in case they show up on next Thursday, you can give it to them.
Yeah. The other thing is, will you be emailing me the final attendance sheet tonight?
It's just, you'll have it before class is over because I'll get it done and emailed out before you even finish.
Appreciate it, bud.
Are you wearing the same shirt as Tuesday?
No, it's short sleeve. No, so you got to know that when my wife buys me clothes, if you notice, they're all like the same color and everything, right?
Yeah, you wear like the same outfit.
Do you understand why, right? Because I can put any pair of shorts and any pair of shirts together, and I don't like clashing. I'm glad to know. So what you reporting?
Yeah.
That's how she knew.
Yeah, and it was left up on my computer, and I was like, wait, he's wearing the same shirt.
No, I try not to wear the same shirt 2 days in a row. It just depends on what I wash. You know, they just get hung back in the closet. And then we just start on that end depending on how everything comes out of the dry. So our finals next Thursday, 6 to 8 p.m. Remember, we've got a little time change. And what we definitely have is a room change for everybody. You folks that are in Brown Hall, that's section 521. You're going to Gilbreth 106. The folks that are streaming, and if you told me you're going to Johnson City, you're going to the same place. If you're coming to Kingsport, as some of you do, you will be in room 336. And then for you folks that are here, 531, you're going to room 336. Is that the same thing I wrote on Tuesday?
Yeah.
I always like to make sure that everybody's going in the right spots. Now, again, you need to bring some version of an ID, calculator. You don't need your formulas and tables because I will provide those for you. Now, what I'm thinking is the finals got 43 questions. I actually did take a look at it. It's got 43 questions. We count like it's out of 40, so you know there's like 3 extra questions there. There's like 15 bonus points if you get more than 40 correct. The thing is when you come to class, you're going to get the test, just like you always do. You're going to get your answer sheet where you're going to fill in the little letters and all that stuff. And then we will hand you the Scantron and a piece of scratch paper you need it. So you're going to do the test just like you've done the other two, right? You're going to answer the questions, you're going to put them on your answer sheet and so on and so forth. The catch is, the reason we're all moving is because when you're done, you're going to come over here You're going to log in at D2L because the room 336 has got computers in it. Your 106 has got computers in it. You're going to log in, and you're going to go to Evaluation, Assessments. Okay? Now, if anybody's going there now, you won't see anything, but what you're going to see next Thursday is there's a Form A, B, Form C, Form D. In other words, there's more than one test in the room that you're taking, and right in the middle of the top of your test will say, you got Form A, Form B, or Form C, right? So what you'll do is you'll come in, and you'll pick this one. Now, I have to do like a little, you'll click it, it'll open up, it'll ask you for a password. Whatever room you're in, the person will have the password, they'll tell you, all right? And what you'll see is this. I have to skip that part because it won't let me go that way. And, you'll come in, and right here's where it's going to ask you for the, I don't know if it's before or after that, it'll ask you for the password. There's no answers here. I mean, there's nothing here other than 43 places to put your answers in. That's the there we go. So you come in, your answer to question 1 is, you choose A, B, C, or D, right? You're going to do that for all. Can I give you a little warning here? I don't know about D2L, but sometimes when you do that, and maybe you scroll, just make sure you got the answer that you think you had. There's no rush here. You get 2 hours to take the test, and it's the same style of test, the same number of questions you've been doing all semester in an hour and 20 minutes. So take your time at the end. Now, you can save every question as you go. It depends on you. I don't know how you want to operate this. Make sure you answer all 43 of them. Don't leave any of them blank. And at the end, after 43 of them, it's going to tell you, submit your question. Right? You click submit. It's going to ask you one more time, you sure you want to do this, I think, and then it's going to give you 2 grades. Okay? That's what's going to happen next Thursday. Make sure you pick the right one. Because obviously you picked the wrong one and put your answer from test A into form B, that won't be a pretty sight. You won't be happy with your grade, and I won't be happy with your grade. And then I'll have to go find everything and say, well, that wasn't what I was expecting. I better go look at the test. Okay. Everybody understand how that's going to work? All right? And again, that's all after the fact. You don't need a computer for anything else other than putting your answers in because we need data. Okay? Now, I think that I didn't show you that on Tuesday, but see they sent me that. Now, I know what. Dude, you didn't tell me. So the other thing I was going to do here in content is, remember I told you I had old finals that you could look at, right? And the answers, just for something. It doesn't matter whether you can do these questions or not. But I've got all of these. I mean, I got like 5 or 6 of them back, all whatever. Hell, they all look the same. You should be able to see them now. Right? So notice I've got all these 1, 2, 4, 6, 7 of them. And then I think I have the answers to all the ones that are there. It's just something to look at so you can get a feel for what the final looks like. They all look the same. Okay? So we've taken care of that. Now, can I give you a little heads up on the final? The only heads up I got is, it's not a time race. It's not a race against time. Right? So what I would appreciate out of you folks is, it doesn't really matter if you finish in 20 minutes or whatever, but I would appreciate if you would read everything that's there. See, this is not a math test. This is a freaking reading test. It's how well do you read. Take your time and read everything, please. Wherever it's at, if they're telling you something about this graph, or we're asking that, don't assume that you know anything about what you didn't read. Read everything that's on the test. Right? If you want to write all over that test by making little things here, they just told me that, or I need to do that, or write all over the test. Because when you're done, we're going to take everything back from you, and it makes no difference, right? You're going to put your answers in D2L is going to grade it. I'll have your answer sheet. If you got to write on the test, write on it. You want to circle stuff, or whatever you got to do. But what I'm going to beg you is, read everything that's there. That's probably my biggest one. This is not going to be a calculation test. I'm thinking normally there's probably, out of the 43 problems, I'm thinking what I saw yesterday. 6, 7, 8. You need a calculator, maybe? Not that many. It's more about what's this mean, what does that say, what do we look here, what are we looking at here, what are we reading here, what should we do here, right? It's all about the interpretation and everything. Okay? What's wrong? They're there too. See the bottom?
Oh,
Yeah, they go at the bottom, right? So there's more than one set of answers on one of those sheets. Yeah. And again, just because you can do those problems don't mean you're going to be able to do the problems here. It's the ideas and the concept and the style of the questions. All right? Now, I haven't forgotten this. I still got a bonus, chi-square, all that stuff. Okay? So, we're at chapter 25. And chapter 25 is called, I'm going to get to the point here, and it's called the chi-square test. Not chi, none of that shit. That's the chi-square test. And what is the story about? It's a story about two categorical variables and a two-way table. There's only a test here, right? Chi-square test. There is no confidence interval. And what we want to be able to answer with this, and as simple as I can make it is there a relationship between two categorical Now, I'm going to use two words interchangeably. You know, is there a relationship between our two categorical variables? Is there a association? I might even spit out, are my two categorical variables independent? Right? These are all the same thoughts. Is there an association? Is there a relationship? Are they independent of each other? Now, in case you don't remember, the way data comes to me and you, and the way we should take care of two categorical variables is always what's called a two-way table, right? That's how we deal with data on a collection of individuals where you're looking at two categorical variables. We make ourselves a two-way table. Nobody cares which variable is the row. Nobody cares which variable is the column. It's just that's how we take care of looking at two categorical variables at a time. All right? Now, you remember I talked about R by C tables back in chapter 6, the number of rows by the number of columns, and then if I multiply the number of rows times the number of columns, I get the number of cells. Yeah? Okay. Now, here's what I want to do. I don't really want to look at this one that's here in the example. If you don't mind, we might as well get to that one. So, this is the one where your E number is an odd number, right? This is the one about wall and abortion. And we were interested to see if there's a relationship. Right, I'm down here. Remember, that was what they were asking here. We want to check to see if there is a relationship between wall and abortion among ETSU students. Assume the students who took the survey as an SRS, right? So, you remember we made two-way table, and I'm going to make this two-way table for you again, and I'll probably end up making it for you a couple times. I can't remember who I put where at what time, but it is their, the wall. I'm going to use for the row variable, and abortion I'm going to use for the column. And that was the one I had made for you to show you what to do there. Now look, there's your two-way table. Everybody agree, right? The rows is what they said about wall, yes or no. Column is about what they said about abortion, pro-choice for life. You notice there's 635 people in the table, so on and so forth. Everybody okay with this, right? And so what we want to know is, I know back here, I know here that, up here you made the table and then you calculated 3 different probabilities and all that kind of stuff, correct? That's what you did there, yep? So The bonus is we want to carry out a test that there is no relationship between what people said about the wall and what the people said about abortion, or there's no association. Or we're asking you, are these two variables independent of each other? In other words, me knowing how you answered about the wall, that meaning independent, doesn't tell me anything about how you would have said about abortion. Okay? Now, the hypotheses here and all this. Now, I'm going to come back to this. I got us started on that thought there. But when we come over here, and I'm thinking about this text, if it's a test of significance, and the chi-square test is a test of significance, right? It's looking to see if there's a relationship between two categorical variables. Well, the null, now anytime I do a test of significance, there's always a null hypothesis and an alternative hypothesis. The null is no relationship. Now, I'm going to put it to you in general terms. No relationship between the two categorical variables. Whatever two categorical variables I am looking at in whatever two-way table you give me, the null is there is no relationship between the two categorical variables. The alternative is, what's the alternative to no relationship? There is a relationship between the two categorical variables. All right, so just to be safe, every time somebody does a chi-square test, the null is a statement that there's no relationship between the two categorical variables, and the alternative is there is a relationship. So when you guys come over here and you're doing your little project, and this one about wall and abortion, what's the null hypothesis is? There is no relationship between wall and abortion. What's the alternative is? There is a relationship between wall and abortion, yes? What about down here? I won't leave you people out. This is the one about gender and textbook. What's the null hypothesis? There is no relationship. What's the alternative? There is a relationship. Right? That's what I just gave it to you in general terms back here, but that's what you're going to tell me there. Now, I got to do more than just show you the project here. You understand, no relationship means no association, correct? There is a relationship means there is an association. What about in terms of the term independence? If there's no relationship, that means the variables are independent. If there is a relationship, that means the variables are not independent. See, I could have stated in terms of independence. The null would be the two variables are independent of each other. The alternative would be they're not. When they're not, there's a relationship. When they are independent, there is no relationship. Normally, and for us, being our last night together, that's a good way for us to think about it. Give me any two categorical variables you want. The null is no relationship. The alternative is there is a relationship. Now, what you'll notice here is, does anybody see any mu's or p's or mu1s and mu2s or any of that shit? No. In other words, you don't see me writing out anything here like that. You see that alternative? The alternatives me and you have had in the past have been one-sided or two-sided. Folks, that's not one-sided. That's not two-sided. That has many, many sides. That's the reason for me writing it out in words and not little symbols here. All right? Now, here's what we want. I would like to do all of this in 2 steps. Okay? The first one is, I want an overall test. It's the chi-square test. To see, or to check, if you like, if there good evidence of a relationship. Now, I got to ask you a question. I'm just concerned about where your heads are at about these tests of significance. If I'm looking for an overall test to see if there is good evidence of a relationship, you understand, a relationship is where the alternative is, right? In other words, what I'm looking for is a test that will give me back a That's when you have evidence in favor of the alternative, when you get a small p-value. I don't give a shit if I'm in chapter 25, chapter 22, chapter 16. Anywhere I did a test of significance, a small p-value always tells me I got evidence in favor of your alternative. And in this case, the alternative is that you got evidence of a relationship. The problem with this test, and it's not a problem, it's just there's so much shit going on here. The test will come back and it will give you sometimes a small p-value depending on your variables that says there is a relationship. The problem is it won't tell you where the relationship is. We need to do some follow-up analysis to describe the relationship. Now, these two go hand in hand. If you got evidence of a relationship because the test returned a small p-value, then we need to do something where, okay, the test is telling me we've got evidence of a relationship. Where in the hell is it at? How are the two variables related? Now, one other thing here. Suppose the test comes back with a large p-value. What does that mean? A large p-value means you fail to reject the null. Correct? The data are consistent with the null hypothesis being true. In terms of two variables, if you come back with a large p-value, that's telling you the data is consistent with no relationship between the two categorical variables. Correct? Is there any follow-up analysis need to be done to describe the relationship? The hell no. The freaking test comes back and says you've got a large p-value. The data is consistent with no relationship. There is no number 2. There's nothing to describe. The only time you got to worry about describing anything is when the test comes back with a small p-value that says you've got good evidence of a relationship. Now, there are no z's, no t's. We got another test statistic coming here. Okay? And there's something called expected count. Now, 1 second. Back here, you see that two-way table? Where I see, okay, the ones that chose pro-choice and said no to the wall, there was 247. The ones that said pro-life and said no to the wall was 121. Everybody see that? You see those numbers in that two-way table, that two-way table came from the data? Those are called observed counts. They are observed from the data. Yes? Everybody follow that. So when I see that two-way table that was calculated from the data, summarized from the data, those are your observed counts. Came from the data. Okay? I want to talk to you about these expected counts that somebody's going to calculate for us. So remember, H0, no relationship. Right? Between your two categories of variables. I'm not going to write that every time now. We're going to assume H0 is true. No shit. How's every test meeting you've done this semester at the end of the semester start? Well, we make some claims. And we always assume the null hypothesis is true to calculate my Z or my T or whatever we were doing before. Assume H0 is true and calculate the expected count. Now, in that original two-way table, every cell is occupied by an observed count. Every cell will have a related, or if you like, a particular expected count that goes with it. Now, here's the deal. This is where I'm at here. I'm over here, and I'm on page 574, and there's a nice little formula, and me being me, I just got to write the damn thing down, even though I'm going to get many tab to do it. I'm on page 574, and I've got these expected counts. I'm going to give you this formula, and I'm going to try to remind you that every time I do these expected counts, one for every cell in my two-way table, we're always got something we're assuming. That there is no relationship, right? That's what it means for H not to be true. There is no relationship between your two categorical variables. And the way you do it is, the expected count, can I just do that instead of writing that shit out every time? What you do is, you take the row total. So every cell is in some row times the column total. Every cell is in some column, and you divide by the just so you remember, there is an expected count for each cell. Now, we're going to do one of these. Why? Because I feel like doing one of these. I'm going to do it back here. Now, you understand, right there, that's a 2 by 2 table. Remember, I don't count the total of the columns or the total of the rows, right? That is a 2 by 2 table. And remember, I would have numbered there are 4 cells, because 2 times 2 is 4. There's cell 1, cell 2, cell 3, cell 4. Can we take a look just for a second here? Let's say it's cell 4, right? Does everybody see the observed count for cell 4? Cell 4 would be, they answered yes to the wall and pro-life to abortion, right? There is 184 in cell 4. There's nothing special about cell 4. I could have picked any of the 4. And so if I come back here, in that two-way table, I'm going to tell you cell 4. What did they say? I'm just going to write it down for you. Yes to the wall. Pro-life. All right? That's cell 4. That's where we intersect here. Now, the observed, there were 184 observed. What does that mean? That means there was 184 that answered yes to the wall and pro-life to the abortion, right? Out of the total. There's 184 of them that was classified as yes to the wall, pro-life to the abortion. Yes? I would like to calculate the expected count, right? Assuming that there is no relationship. So the expected for that cell will be what? Remember, it's a row total times a column total divided by the table total. Well, what row is it in? It is in row 2. What column is it in? It's in column 2, and then the table total is 635. So the row is 267. The column is 305. Let me say that again. 267 times 305. And I hope somebody got a calculator tonight. It's okay, just give me a minute. So that's the expected count, right? Its row it's in, times its column it's in, divided by the table total. And that is all calculated assuming that there is no relationship that the null hypothesis is true. You understand, you're not going to get 184 here. Which year? 128? Point something? So in other words, if there was no relationship between the two categorical variables, we would have expected 128. Say 128. I got it right. You would have expected 128 that said yes to the wall and pro-life for abortion. What did we actually observe that said yes and pro-life? 184. Notice, we've got way more than we were expecting, right? If there was no relationship. Everybody follow that, right? Now, could I have done that for every cell? And the answer is yes, it could. Now, you know, I got to show you this part, right? Stack, table, cross-tabulation, option, maybe not. Chi-square. Let me go a little slower. This is where we were at earlier, right? Where we made the two-way table. Remember, I got my row variables, the wall, column variable, the abortion, and then I went to chi-square. You see right there where it says statistic to display in each cell? Expected count. We'll see if she's right. And she did. So that's the same two-way table over again, except every cell has two numbers in it, right? The number on the top is the observed, and the number at the bottom there is the expected count. Everybody follow? See, they don't say observed, they just say count, but that right there is the observed. It says the cell contents, right? Okay, so what numbers are in there? And it's always going to be the observed, what came from the data, and then it's going to be the expected count that we would have calculated by hand. So there is one for every cell. There's an observed, obviously, from the data. There's an expected that we calculate. And so my calculation was exactly correct, right? Now, is everybody okay with where we're at here? I mean, I got really nothing going on other than, you know, I get one of these two-way tables. The observed are what comes to me, and then we're interested in calculating these expected, and it's always the, and I'm sorry, my hands move like this, it's the row total times the column total divided by the table total. Because I'm pointing where the little things are in your two-way table, right? Okay. I'm going to kind of say, you know, okay, there's one of these for each one. Now I'm ready for the chi-square test. All right? And I'm going to be loud as usual. And the chi-square test is, or does, see, here's our problem. There are no X bars, right? That's where the evidence came from with mu. There is no p hat, all right? What there is the chi-square test will compare observed, and if you don't mind, I'm going to shorthand that to that, observed counts to expected counts. Now, I'm going to, you know, normally when we do a test of significance, my hands are moving all over the freaking place like this, right? You know, the mu and the null is telling you you're here, or the p is telling you this, and I'm going to start telling you the p hat or x bar is this way, and the further out the tail you are, the stronger the evidence against it's not, the smaller your p-value, right? Not tonight. Tonight I'm going to do this. Because every cell has an observed and an expected. And the chi-square is going to measure how far they are apart. Right? They're going to compare that. And so, I probably should write down the little chi-square statistic. Your chi-square statistic. And it looks like this. That's the Greek letter chi, the best I can write. We put the little 2 up there because that's chi-squared. And we're going to add something up here. How do I know that? Because I see in the book there's this big capital letter sigma, and every time me and you see that, that means add. And what we're going to do is, we're going to take the observed minus the expected. Now, I'm going to say something here. So, this is over each cell. We're going to do that. We're going to do this piece right here. Whatever I do here, I'm going to do this for each cell. So in each cell, there's an observed count. There's an expected count, right? I'm going to take the observed minus the expected. Can these numbers be both positive and negative? Well, it's positive if the observed count is bigger than the expected, right? But it will be negative if the expected count is bigger than the observed, yes? You know, math people, I don't like shit when sometimes when I do it it's positive, sometimes it's negative, so we square, make them all positive. You understand, that's still a distance between the observed and the expected, correct? It's still measuring how far they are apart. And then I would like to divide by the expected. So, you know, it's giving me like some ratio of, or difference squared to what the expected count is. However you want to think about in that red box there is, it's measuring how far they are apart. If the observed count's 300 and the expected is 100, that's a long way apart. This is going to be a rather large number. If it's, you know, the expected 150 and the observed 140, those aren't very far apart, are they? The further they are apart, the larger this value is. You need to know that what are we taking the sum over? Where are we adding? You take the sum over all steps. Now, I got to tell you, just like I always tell you, you know, your t-score measures how many standard errors, your z-score measures how many standard deviations. This chi-square statistic is a measure of the distance of the observed count from the expected count. That's what it's measuring. It's measuring how far they are apart. Okay. Here's where we're going to see what the test tells me. Large values of your chi-square. That is your test statistic. Normally when me and you do a test of significance, large values of our test statistic give me evidence against the null and in favor of the alternative. Same. Evidence against H0. If you don't like it in terms of against, a large value of your chi-square statistic will give you evidence of a relationship. How's that? Maybe that's simple. What it's saying is the expected and the observed counts are far apart. So I'm going to look at everybody for just a second here. How in the hell do I know if I get a large value of my chi-square statistic? How do I know that that's giving me evidence of a relationship, right? If it's against the null, evidence against H0 in favor of the alternative. That's our standard thing me and you say when I get a large value of my test statistic. How do I know that? Well, remember, the observed comes from the data. The expected are calculated assuming that H0 is true. What it's telling me is the expected and the observed are far apart. Something has to be wrong because the observed were observed. The expected were calculated assuming that H0 is true. What's wrong? H0 is not true. Right? Because you calculate all those expected accounts assuming that there was no relationship. Well, they're so far away from what you're observing in the data, what's wrong? Your expected counts are wrong. Why? Because there is actually a relationship between your variables. That's why they're so far from what you're observing. This is the one we're always shooting for. Because eventually, give me about 10 minutes, when I have a large value of my chi-square statistic, this is the one that will give me back a small p-value as always. Anytime I give a large value of my test statistic, it always produces a small p-value. Okay? What's the other side of this? Small values of chi-squared statistic. Are not evidence against H naught. Translation: the data are consistent with H not being true. The data are consistent with no relationship. The data are consistent with the expected and the observed counts are close together. Right? You get a small value of your chi-square statistic. You calculated the expected counts assuming that there was no relationship. That's actually what you're seeing. The expected and the observed are close together, so you're safe. Now, I still haven't finished that problem back there. I've still got one more little thing to check to give me everything I want in this chi-square test. But a couple things here. I can't let this just go, and I can't just say we can do this all the time. You know, there's things that need to be checked here, and I'm going to start with this idea. Okay, I'm going to first give you what I'm going to call cell counts required. This is to trust your chi-square statistic and your p-value that I'm going to show you. And I am on page 583. And when I say cell counts required, it's actually, there's something required about the expected counts that get calculated, whether we calculate it or we get the software to calculate it. Okay? And here's what it says. You can safely use the chi-square test with critical values from the chi-square distribution when no more than 20% of the expected counts are less than 5. No more than 20% of the expected counts. You can't say anything about the observed. The expected counts are less than 5. So the book will take this one step further. If you have a 2 by 2 table, that means you have 4 cells. You can't have any of the expected counts being less than 5 because 1 out of 4 is 25%. Okay, so I just stick with no more than 20% of the expected counts are less than 5. So you have a particular number of cells in your two-way table. You have how many of the expected counts, how many cells have expected counts less than 5 due to division. You know, if I've got 6 cells in my two-way table and one of the expected counts is less than 5, 1 divided by 6, is that less than 20%? Yes, you would be fine. All right? So the way I think about this is, you know how I always list conditions that need to be met? That'd be number 2. You got to know with me that couldn't have been number 1 I was going to write down, because sure as shit you know what number 1 is. Okay, maybe you didn't. I sure the hell hope you did before Thursday. Oh, good God. Now, this time is this. See, if you think about it, there's one way, if I had a simple random sample, right, then all I do in my two-way table is I classify everybody in my simple random sample by the 2 categories of variables, correct? There's another way I could do this also. Still got simple random sample, but I can have 2. I can have one from this group and one from this group, and how would I classify everybody? Well, there's one categorical variable I want to measure, and I would classify them by the categorical variable, same one in this group and this group. And what would be the other classification? Which group are they from? Are you from this group or this group? Right? So they're still classifying everybody by two categorical variables, right? Except there was two simple random samples. And still my self counts need to be required back there. Everybody follow? See, this one over here, you're looking, and this one here, they've told me to the top to assume that this can be an SRS from ESU students, right? So how are you classifying? Oh, well, you got a single simple random sample, and you're classifying everybody by the two variables, right? Whether they said what they said about abortion and what they said about walk. That's a single SRS. How can I turn this into a two? I got this group that favors the wall, and I got this group that doesn't favor the wall. I take a simple random sample from this group, I take a simple random sample from this group, and ask them about abortion. How am I going to classify them? What they feel about abortion, and which group were you in? Would I get the same table? Yes. Point is, either one simple random sample classifying everybody by both, or two of them, and one of them is classifying by which sample you are from. All right, no big deal. This is a single one here. And the one below it, above it is 2. Now, I got to do this. Just because it's like different than what we normally look at. There's something called the chi-square distributions. Notice plural, like t-distribution, there's more than one of them. It turns out there's a family of them. I like to work the term family into math class, especially in the last night of class, right? Family of them. It turns out they take positive values only. That means bigger than or equal to 0. Nothing here is ever negative. And the other screwed up part for us at this point is they're always what's skewed right mean? Where's the tail going? We're practicing for next week. If it's skewed to the right, the tail's going to the... Oh, no. If it's skewed to the right, remember, it's not where everything's sitting, it's where that tail goes, right? So if it's skewed to the right, the tail's going out to the right, yes? If it's skewed to the left, the tail's going out to the left. Yeah, I know when you're skewed to the right, the main part of it's down here on the left. No, it's where the tail goes. Okay? Now, if there's a family of them, we have to have some way to pick out the one we want to work with. So, you specify by giving its degrees of freedom. Sound familiar? We did the same thing on Tuesday this week, Thursday last week with the t-distributions. Now, here's the thing. If I have an R by C table, everybody know what I'm talking about, right? There are R rows, there are C columns without the total. What I'm telling you is whatever categorical variable is the rows, there are R. What word would you like to use? Classification, categories, groups, right? In other words, you've got R rows, you've got C columns. In other words, your column variable has C categories or C groups or freaking C places I can put people in, right? The degrees of freedom is always DF for me and you, whether it's T distributions or one of these chi-squares. It's the number of rows minus 1 times the number of columns minus 1. So if you have a 2 by 2 table, you will have 1 degree of freedom. If you have a 3 by 2 table, you will have 2 degrees of freedom. If you've got a 10 by 9, what am I going to have? 72 degrees of freedom. If I've been doing all that shit right in my hand, taking 1 from each one and then multiplying. That's all well and good, but here's what they all look like. Right there's 0. Remember, they all take positive values and they're all skewed to the right. So what lives down here, this is where your chi-square statistic, that little chi-square lives. And so somewhere, there's your chi-square statistic Yeah, it's not quite an X. Your chi-square statistic, you know that you calculated by taking the observed minus the expected and squaring and divided by the observed and add all the little pieces up. Here's where your p-value is. All I got to do is look at the area in the tail. As extreme or more extreme than your test statistic that was calculated from the data. As always, obviously, the larger your chi-square statistic, the smaller your p-value. The larger the chi-square statistic, the further out the tail you are, the less area that's in the tail. Hell, maybe I should have asked you this while we were here. What's the area under this curve? We didn't get that shit, did we? It's a density curve, yes? The area is 1. The further the chi-square is out the tail, the smaller the p-value. That means the larger your chi-square statistic, the smaller your p-value, and my hands are going to move like this. The larger your chi-square statistic, the smaller your p-value, the larger the chi-square statistic, the further the observed and the expected are apart. What the hell's wrong? Your null hypothesis is wrong. You shouldn't assume that to be true. It's not the fact that there is no relationship, there is a relationship. Okay? Now, I think I have enough. Well, what I really think is I probably tormented you enough for 28 ranks. It was only actually 26 because we had 2 tests. Of course, I probably tormented you those ranks too. Now, we've already talked about, I'm going to go, and I'm going to actually look at both of these because I just find them both rather interesting, right? So this is the one we were talking about that I got the two-way table for, yeah? That I did the expected counts for you and all that. And it says, state the null and alternative hypothesis. Everybody got that? I don't care which one you're in, the one in 5 whatever and 5 whatever. The null is always, there's no relationship between the variables, the category variables, and the alternative is, there is a relationship, right? Now, we want to do this chi-square test, and there's no way in hell I'm going to do all that work by hand. So, what's wrong? Okay, so here's the thing. You see that? I'm just going to scroll down. You see that two-way table I got? Remember, each cell had the observed and the expected. And notice they are rather far apart, right? You know, cell 1's got 247 observed, 191, 121, 176, 83. They are rather far apart. Okay, let's say we didn't even notice that. So now I'm going to come back to stat, table. I'm taking you right back where I made the two-way table, where I got the expected counts and everything. I'm going right here to cross-tabulation. In case you don't know, that's cross-tabulation and chi-square. I'm going to choose it. I got to let the rows be one variable and the columns be another. There's no need to change that. I'm coming down here to chi-square. All right? I want to do a chi-square test. I didn't check it before. There's my chi-square test. I'm going to leave the expected counts for you, and then I want one more thing checked here. Right? I always like to see, you know, the observed is going to be there no matter what, because that's coming from the data. I always like to see the expected counts, and I like to see each cell's contribution to the chi-square statistic. In other words, I want to see that observed minus expected squared divided by the expected, but I want it broken up into each cell. I always do this, whether it was me doing it or showing you, I would always choose the expected count, each cell's contribution, and don't forget to tell it to do the chi-square test. You won't know what the hell you're doing unless you do. If I click OK, and I'll click OK, now it's the same table coming back, except you see where at the bottom here it says cell content. Observed count, expected count, contribution to the chi-square, right? So there's 3 numbers in every cell. Cell 1 has 247 observed, 191.2 expected count, and the contribution to the chi-square statistic is 16.26. Now, it will add all these together for you. So down here at the bottom, there's a chi-square test, and I'm interested in the Pearson part. I'm not interested in this likelihood ratio, even though you're going to take it all and put it over there. I'm interested in Pearson. It says chi-square, folks. your chi-square statistic, it's telling me right up front, dude, that's 80.488. Now the question is that large or small? Well, let me add just one thing that I didn't mention. With the chi-square statistic, the degrees of freedom is actually the mean of it. So, if the degrees of freedom is 1, the mean is 1, you're looking at 80.488. Are you a long way away from the mean? Damn straight you are. So, this is what I would consider to be, I always do this to you. I can't help myself. Large. So, if I've got a large chi-square statistic, I got a large test statistic, I didn't even pay any attention. Do you expect a small or large p-value? I just keep trying to brainwash it. Your p-value here is, what is it? Now you know it can't be 0, right? It can't be 0, but approximately, my two little squiggly lines. I can't tell you it's 0 because we know if I took enough decimal places, there would be a number pop up. So it's approximately 0. And do not freak out on Thursday if nobody writes the term p-value and they just say, we did a test and p is, they just use capital P, right? Depends on who wrote stuff, they may use that. So then, here's my question. I have a large chi-square statistic. I got a small p-value. What the hell is your conclusion? What would I do every other test we ever did? I would you agree? Yeah, small p-value. We don't believe the null, we believe the alternative, right? So let me ask you this. In terms of this chi-square and relationship, no relationship, what do we find evidence of? Folks, I found all the evidence you've ever wanted of a relationship between what people think about the wall and what people think about abortion. My p-value is virtually 0. Okay? So, I give it to you in general terms. What I have here is I got evidence of a relationship. All right. Now, when I go back and look at your project here, it's going to tell me some crazy shit about, okay, what's your test statistic are you using? That's your chi-square statistic. What was the value? Whatever the hell you wrote down there. State your conclusions and decision and conclusion for the test. Oh, I want to reject H naught, and I'm going to tell you I got evidence of a relationship. Examine the conditions. Are the conditions for inference in part 2 violated? But what conditions am I supposed to be worried about? I'm supposed to be worried about if I have a simple random sample or 2 of them. In this case, I'm only worried about 1 of them. And then I got this little story about expected counts, right? I'm thinking about this right here. Now, Minicab is very bright. Minicab is so bright that if there were any expected counts that was less than 5, it would have told you at the bottom. Because it knows it's a problem. Well, look at the expected counts. 191, 176, 138, 128. Are any of them less than 5? No. You have an expected count worry here? No. All your expected counts are greater than 5. You have a simple random sample. How do you feel about our result? I'm very happy the conditions are met. Now, I could let it go. Because, see, nobody cares anymore about this. We stated our hypotheses, we performed the test, we included the output. We said, okay, what was my test statistic? What was its value? What was your chi-squared? What was its value? State your decision and conclusion for the test. And you notice, they're actually giving me a significance level up here at the top. Well, hell, your p-value is less than that, right? So you got significant evidence at the 5% level of a relationship. And then they want me to examine the data, check the conditions. Did you have a simple random sample? Tell me about the number of cells that have expected counts less than 5. There were none. Nobody asked you about what the relationship is. And, I know it's our last night, and I should just say, okay. No. Here's my thing. You see this table? I always, when I get a small p-value and the test is trying to tell me you've got evidence of a relationship, I always go back and look at the observed and the expected count. That's how I do the follow-up analysis. Now, if you look at the ones that said no and pro-choice, there's fewer expected than what actually was observed. And then pro-life that said no is the other way. Right? There's more expected than actually was observed. If I look at the ones that said yes to the wall, 83 were pro-choice, but we were expecting 138 if it didn't matter. They were independent. There was no relationship. And for yes to the wall, pro-life, we observed 184. We were expecting only 128. They flip-flopped, doesn't it? See, here's the deal. The relationship is, if you said yes to the wall, that second row, then what was observed, you were more likely to be pro-life, yes? Then what we were expecting to see if there was no relationship, everybody agree? And let's take this for the sake of things. Let's say you said no to the wall. Then you were more likely to be pro-choice than we were expecting. Because we were only expecting 191, well, hell, 247 of them actually answered it that way. So if you said yes to the wall, more likely to be pro-life. If you said no to the wall, you're more likely to be pro-choice. You want me to put this in terms of Democrats and Republicans for you? I don't like to get into politics. I'm just reading the data. I got to do one more thing with this, and then we'll look at the next one. Right? There's something up, and what's up is it makes a difference on what you said about abortion, given what you think about the wall, or it makes a difference on knowing what you said about abortion on how you feel about the wall. They are related. They are not independent. One influences the other. How's that? Look, I got to do this here. I know I've done this for you already. And this guy, no, you don't have to do this because you've already done this. I'm going to bring this guy back up again. And I want to look at this two-way table, and I want to look at the two-way table of, I'm going to do, abortion's been around for a long time. This whole wall crazy shit's just been going on recently. And I want to make sure I show Y as a percent within categories of 1. This is the cluster bar graph that I gave you when we first talked about number 5. And then I looked at this and I said, okay, so there's two conditional distributions. The one on the left is conditional distribution of wall, given that the person said pro-choice. The one on the right is a conditional distribution of wall, given that the person said pro-life. And what I asked you back there is, do these two look the same or do they look different? See, because if these look the same, it's trying to tell you there's not a relationship. If they look different, it's trying to tell you there is a relationship. Do they look the same or do they look different? They look different. Hell, they're flip-flopped. Yes? Pro-choice, which one has the highest percent? No. Pro-life, which one has the highest percent? Yes. The height of the bar is flip-flop. This is exactly the kind of picture that I'm expecting to see when I tell you the p-value of your chi-squared test is 0, you got evidence of a relationship. And if you think about what I told you, I know it's the last night, but I'm loud. My relationship, I just told you, right? See, look, if you said pro-choice, you're more likely to say no to the wall. If you said pro-life, you're more likely to say yes to the wall. That's exactly the same thing I told you when I was looking at the observed and the expected counts in the two-way table. Same thought. In other words, I got like 3 ways to think about the same thing. The chi-squared test will tell me, hell, what it's asking you is, are these two conditional distributions the same or not? Are my two clustered bar graphs the same or not? Obviously, there is a relationship between what a person says about the wall and what they answered about abortion. Okay. I beat that problem to death. We've done everything there. Remember, please do not forget the cell count, simple random sample. Let's do this one. So again, the null and the alternative is, the null is still no relationship, the alternative is there is. So we need to come back over here, and I need to do this. I'm going to do it all at one time. I won't break little pieces down now because I want it all. Cross tabulation, chi-squared. I don't care which variable you put where. I need, what was it, gender and something something? What was the other one, textbook? We wanted to know if there was a relationship between a person's gender and how they like to read a book, right? Whether in paper, is that the one? Online? And then, just to make sure, because, if you people are doing this one, you're going to come in, you're going to do this, make sure you go to chi-square, make sure you have the chi-square test checked, expected counts, each cell's contribution. To be honest with you, what you guys need is the p-value for your project, but I just can't let it go like that. I'm going to click OK. And I'm going to click OK. Now, before I show you the p-value, notice this time you have what kind of table? You've got 3 rows and 2 columns. You've got a 3x2 table, right? So you're going to be looking at the chi-square distribution with 2 degrees of freedom. There is your expected count in the middle, right? It's always read, observed, expected, contribution, that little chunk of the chi-square, yeah? Notice, in cell 1 it said female, and in print there was 308 observed. We were expecting 295. For the males it said, on an electronic device, we observed 69. Hell, we was only expecting 58. For the males it said in print, we observed 170, but we was expecting 180. Right? So I'm just reading the observed and the expected, right? First one's observed, next one's expected. The reason I know that is because of that line right there, right? Count, observed count, expected. Yes? Are we okay with this? Now, I'm going to come back here. It says perform the test and including the output. So you're going to take that whole box and put it over there. It says which test statistic are you using? Obviously the chi-squared. What's its value? I didn't show it to you yet because I'm going to do this. Okay? I'm going to leave that there, and I would like to look at this again. I'd like to look at the bar chart, cluster. This time I want to put in the person's gender, and then the textbook. Make sure you've got show Y as a percent within categories at level 1. The reason I didn't want to show you the p-value yet is because I'm looking at this and I want to know if I'm asking you about, are these 3 conditional distributions the same or are they different? What I want to know is, does it make a difference if I know your gender on how you want to read a textbook? That's asking you, well, I'm looking at 3 conditional distributions of a textbook given a person's gender. If they are different, then your gender makes a difference. If they are the same, then they're not related. They are independent, and your gender tells me nothing about how you want to read a textbook. Are these 3 the same? And the answer is males and females are similar, right? The other flip-flop. Right? The other, you're more likely to tell me that on an electronic device. Males and females, you're more likely to tell me that it's in print. Everybody following? I'm picking out the highest, the tallest bar here. The group that has the largest percentage. So let me ask you this. Looking at this, what are you expecting? Forget the chi-square statistic. Are you expecting a small p-value or a larger? Is it because you don't want to talk to me or because we don't know? I see a difference in the 3, right? The one all the way to the right is completely different than the 2 that's right. And there is some difference between males and females. For some reason, I'm expecting a small p-value. So your chi-square statistic here is 8.155, and your p-value is 0.017. Is 0.017 small or large? That's small, right? So that chi-square statistic, this time being 8.155, must be large. Remember, the mean of the chi-square distribution is always equal to the degrees of freedom. Hell, you're 4 times the mean here. I don't even want to talk about the one that had 80 or whatever. Hell, he was 80 times the mean there. He was way out the table. You had all kinds of evidence. So it turns out that there is evidence of a relationship here. And it wants to know, well, do it at the 5% level. Yeah. I want to reject H naught in favor of the alternative, and I've got significant evidence at the 5% level of a relationship between a person's gender and how they like to read a textbook. Examine the data. Are the conditions for inference in part 2 violated? You know it's a simple random sample because they told me that at the beginning of the problem. Assume we form an SRS of ETSU students. What about the expected count? Remember I told you that Minitab was smart and knew when we were going to have problems? Does everybody see right below where it says chi-square test? 2 cell counts, expected cell counts less than 5. Damn, it knows that when you've got expected counts less than 5, there's a problem. How many cells do we have total? So I'm just going to do this because you need to make a note of this if there's 2 that are less than 5. So 2 out of 6 is what? Yeah? Is that right? 1/3, 33%? You can round to 34, 33.3, repeating, whatever you want. I'm just thinking 33%. What was I supposed to be worried about? If I had no more than 20% of the expected cell counts to be less than 5. I got 2 out of 6. I got 33% of them. How do you feel about all the work we just did? I don't feel good. Please, when it asks you this part, and it's only in this one, are the conditions for inference met? Yes, it's a simple random sample, we're told that. But we have 2 out of the 6 expected counts are less than 5, which is 33.3%, and we're supposed to have less than 20%, so our p-value may not be as accurate as we would like. Actually, we should have stopped and not passed go and never answered any of the questions above. Look, I don't know how. See, the ones about the males and the females, that's pretty close. The others, the ones where the expected counts are less than 5. Look, if we could get more in the other group, that may change what we think. Because, you've only got like a few people answering that way and said whatever they said. Everything's a little iffy here. Okay? Please make a note that there was 33.3% of the expected counts was less than 5, and you're not supposed to have more than 20%. You have violated the conditions, so I don't really trust the results of the chi-square. That's the safest way to say it. I know they ask us to answer the questions, right? State your conclusions, this decision and conclusion for the test. I understand this is what I would like to do, but as soon as I check the conditions, I don't want to do that. Okay? Is everybody all right with that? Does that make us even on the project now? We've done everything that I promised. We talked about every problem at some freaking point or another here this semester, right? Okay? Now, when you're studying for the test, make sure you know the conditions for whatever chapter we were in. Remember, it's always a simple random sample or worst 2 of them, right? Remember, there's always this thing about population distribution, and I'm not thinking about tonight, right? The population distribution should look, symmetric, single peak. Sometimes we say approximately normal, right? We never know mu, we never know sigma. Even in the one about proportions, we thought about we had to have a simple random sample. Depending on whether you're doing the confidence interval, the test significance, there's something about successes and failures that's got to be counted, right? I would always just make sure I knew the conditions. And you remember on Tuesday when we did T, when we finished the T up, there was that table about robustness. Remember that one? Now, I wouldn't be like this spouting off at the head if I didn't think it was important that you looked at it again. And the table I'm talking about is on page 466. When you can get away with using T. Remember, if you're between 2 and 15, you can't get away with anything. Between 15 and 40, you can get away with a little bit of skewness. Bigger than 40, we're all happy. And then when I went to the next chapter, I added the sample size because those were 2 sample problems. Just look at things like that because there's no calculation. It's just, can I trust what the hell I'm looking at? All right? That's my thought. Now, the last thing I'd like to do for you is remember that we're all even except for me grading your project, and you'll never get that back. I know. I always return everything. No, you ain't getting that back. Oh, I'll grade it, right? I'm going to grade it, and I'm going to post your grade to D2L, but you're not getting it back. Remember, you're going to actually upload it, right? You're not going to email it to me. You're going to upload it. Just make sure everybody knows. You're going to upload it to me. Where the hell is it? Dropbox. Right? It's called Capstone Project. You got till tomorrow at 5 o'clock. The other thing I'm going to do is I'm going to post the solutions to you, for you. Right? We went through and looked at somebody went through and made solutions for you. It will show up Saturday morning. What's tomorrow, the 26th? I got it set to show up on the 27th at 1 a.m. I was told to do it after the 26th was over. Yours guys' stuff is due for me on Friday, tomorrow at 5. Notice the solution will show up April 27th, which is Saturday morning at 1 a.m. I'm hoping you're not studying at 1 a.m. at that point, but you might. At least Saturday morning when you get up, the solution will be there. You're going to upload to the Dropbox, not email it to me. You got to get it done before 5 o'clock, and if we've been playing along all semester, we've been working at this, like 5 weeks now? And then what we did tonight was like when you go home to do it, maybe that's a 15-minute issue. And if it's longer than 15 minutes, just pull up the freaking video because I didn't look. Right? I think I answered everything thoroughly there because I wanted to use that to teach you about the chi-square. And you're going, where else are you going to see this? Well, chi-square shows up biology. Places like that. And, it's just kind of nice because you're talking about two-way tables, two categories of variables, chi-square counts. So we're even here. Here's what I would like to do before we go. I want to show you how I'm going to calculate the grade at the end. So, here's what I've got. How many homeworks do we have? Like 7? I think there were 7. Right? So I got 7 homeworks. And it turns out, when it was all said and done, and I looked at everything and saw what we had, there was 157 things I checked for. Oh, good God. In other words, all the denominators added up to be 157. Does that sound right? I checked that. Somebody emailed me about it. And I'm thinking, so in other words, I got something, and all I did was, every time I gave you back a homework, there was a fraction on there, right? You get 19 out of 22, or you got 11 out of 13, or whatever the hell it was. The bottoms all added to 157. What I'm going to do is add all your tops up. All the ones in the numerator, yes? And then, remember, your homework's supposed to be out of 250 points, so the way I turn that into 250 points is, I just take that proportion of the answers you got right out of the total possible, multiply by 250, and that will give you your homework points out of 250, all right? And then, I've got my tests. Remember, these were always out of 40. And the way I think about your final hill, it's out of 42. So, how would you like for me to calculate? I mean, there's 2 ways I can do it. If you're going to think about some number out of 40, you're going to multiply each of these by 200. Or you could just take the number right and multiply by 5, either way. Okay? So how many points I got there? I'm at 850. Yeah. The capstone project, again, that you'll never get back, is something out of 100. And there's a little bonus on there, so there's a little more than 100 points there. So don't freak out when I post your capstone project grade in D2L in the grade book, and you got like 103. Remember, there was the bonus we talked about tonight. So there's a little more than 100 points there. And then, what's the other thing? If that's 950, the learning curve is 50. Those are out of sapling learning. Turns out there's actually 19 of them. For every one of them that you hit the target score, I give you 2.5 points. If you do all of them, I give you an extra 2.5 for a total of 50. 19 times 2.5 is 47.5. You do them all, I give you another 2.5, which is 50 points. I almost feel like those are free points. I mean, it's just sitting down in time to do that. Remember, Those have to be completed by Sunday. April 28th at 11:59 p.m. I think is the last day of those. So if you'll notice here, I believe if you check me out, I got 1,000 points here, correct?
Mike, there's also the survey they took at the very beginning of the semester.
Thank you, sir. Hey, somebody got to keep me honest. There's actually two things, right, at this point. There's that 1,000 points there. He remembers that survey where you posted the pictures for me, or I don't know what they call it, the picture of. You put it in D2L, right? I never gave you those 5 points. They get added in here too, right? I've got the class survey. So that's a possible +5 if you did it. There's no ifs, ands, or buts. And then we've got attendance. And the way I always think about the attendance is it's a possible. Every time you miss a class, we take 10 away. Right? So at the end of this semester, when I put all my shit together with all the Rob stuff, and I see you miss 2 classes, you'll see 30. If you didn't miss any classes, you'll see 50. And surely to God, nobody actually missed a class and not watched the recording and email. Because if you have and you haven't, because I got a stack of emails that says 1530 attendance, and there's like 7,000 of them. So surely if you missed class, you'd already emailed me. I hope. Right? Because that was 3 points too, whether you were here or not. So what do I got here, like 1,055? Remember there's 3 extra questions on the final. Right? So what are we looking at, 1,070? Now, the grading scale is on a 1,000-point scale, and it's on the syllabus in D2L. I have to look at it when we get to that point. That's how, I got to do it. The other thing is this, I know we're done. At the end of the semester, don't freak out. I can't give you your final grade till after Thursday, right? But you'll know because you'll see all the points. You'll know how many points you got now, right? You'll know everything except for the capstone. Yeah. As soon as I get everything posted in D2L, I will send everybody an email saying everything's posted, the grades are posted. I asked you for one thing. Let's say you get this number of points, and it's supposed to be this letter grade, but then, maybe it was a C+, and I gave you a B-. Right? Don't freaking email me. Have a good summer. The only time you email me is when it was in my favor. Excel did something stupid and I didn't get something right. But, if the letter grade's a little bit higher than what the point total is, let's go home. Be careful. We will see everybody next Thursday at 6 o'clock somewhere, right? Either in Gilbert 106, you folks here, or 336.
Mike, that email should have been sent to you, and it'd be in your inbox.
I appreciate it, bud. Hey, will I see you again in the fall?
There's a good chance.
All right. Well,
Better chance than normal, because if I'm here, I'll probably be working your class, and I'm going to be here. So.
All right. Yeah. So we'll see you in the fall, right? We'll see you like in August. Yep.
Yeah, I guess we'll be back over in 202 on this end.
Yeah, I'm assuming you'll be doing both the classes, and they'll both be in Sam Wilson, because they're back to back.
Yeah, back to back, Tuesday, Thursday. If Dia gives me the class, then I'll be doing both of them. So.
All right, man. So have a good summer.
Okay, I'll see you in August.
All right, buddy.
Wait, we don't have